All right, this is lesson 41. We're talking in this lesson about the probability of two independent events. So we say that two events, A and B, are independent if the probability of one event does not influence the probability of the other event. They do not affect each other at all. If A and B are independent, then the probability of both A and B occurring this is the probability of A intersect B, and it's the two probabilities of each one of them multiplied together. So suppose I roll a 6-sided die and draw from a 52 card deck. What is the probability that I roll an even number and draw an ace? So these two events are independent, right? The fact that I roll an even number does not at all affect the probability of drawing an ace. So I'm going to call A rolling an even number. What's the probability that I roll an even number on the dice? Well, there are 3 even numbers out of 6, so this is 1/2. And I'm going to call event B drawing an ace. What's the probability that I draw an ace? It is 1 out of 13. So the probability that I roll an even number and draw an ace is equal to 1/2 times 1/13, which is 1 over 26. Okay. Our next example says out of all the emails a secretary receives, she receives one from her boss 33% of the time. She also randomly drives to work instead of walking 98% of the time. What is the probability that she opens an email from her boss at random and drives to work? Round to the nearest thousandth. So these two probabilities, emails and walking, have nothing to do with each other. They are independent from each other. So I call A opens an email from her boss, and the probability of this is 33 out of 100. And I'm going to call event B drives to work, and this is 98 out of 100. So the probability that I open an email from my boss and drive to work, since these are independent events from each other, I multiply 33 over 100 times 98 over 100, and if I multiply these two things together, I get 0.323, or 32.3%. So this is the chance that she randomly opens an email from her boss and drives to work instead of walking. Again, this multiplication of A and B, their probabilities, only is the case when A and B are independent from each other, meaning that they don't affect each other in terms of probability. All right, that is it for today. Have a great weekend, and I will see you all on Monday.